This line sets the scene for a multiple-choice question about data scaling using scikit-learn's MinMaxScaler. We'll examine how the scaling changes the data's properties. Think about the minimum, maximum, range, and average values. This is one of the multiple-choice options. The question is whether the smallest value in the scaled data will be 0. The MinMaxScaler is known for its scaling effects, so this is a test of that knowledge. Another option: will the largest value become 1 after scaling? This option asks about the overall spread of values after scaling. If the minimum is 0 and the maximum is 1, what does that mean for the range? This is the final multiple-choice option, asking about the average value after scaling. It is testing understanding of whether scaling changes the mean in a predictable way. This line provides the original dataset that the MinMaxScaler will process. These are the numbers that will be scaled. This is the starting point for our calculations and analysis. This is the name of the function, which stands for MinMaxScaler. It is a technique used to standardize data to fall within a range. This represents the scaled version of feature vector x. This is the result we want to analyze after the scaling operation. What will be the characteristics of this set of numbers? This multiple-choice option explores whether the mean of the scaled data remains 0.5 after applying MinMaxScaler. Let's think about it. MinMaxScaler scales data to a range between 0 and 1, but it does not preserve the original mean. It shifts and scales the data. Therefore, the mean of the transformed data is not guaranteed to be exactly 0.5. It will be close, but not precisely 0.5. We calculated the actual mean in the solution steps as 31/56, approximately 0.55. The option is incorrect because the transformation changes the mean. This option checks the understanding of the effect of MinMaxScaler on the minimum value of the dataset. MinMaxScaler guarantees that the minimum value in the dataset will always be transformed to 0. This is because the scaling formula subtracts the minimum value from each data point before dividing by the range. Therefore, the minimum value, which is subtracted from itself, results in 0. This option tests the impact of MinMaxScaler on the maximum value. Similar to the minimum value, the maximum value is always scaled to 1 by MinMaxScaler. This happens because the scaling formula divides the difference between each data point and the minimum by the range, maximum minus minimum. For the maximum value, this difference equals the range, leading to a scaled value of 1. This option focuses on the overall range after the transformation with MinMaxScaler. Since the minimum value becomes 0 and the maximum becomes 1, the range of values in the scaled data will always be 0, 1. This is the core functionality of MinMaxScaler, to constrain data within this specific range. This is a multiple-choice question. It tests your understanding of how the MinMaxScaler in scikit-learn works. Are you ready to tackle it? This question asks you to analyze the results after scaling the feature vector x using MinMaxScaler. The goal is to determine which statements accurately reflect the characteristics of the scaled data. Let's carefully examine each statement to see if it aligns with the outcome of the scaling process. Here are the results after applying the MinMaxScaler to the input feature vector x equals 1, 5, 10, 15. Notice that each original value has been transformed. The minimum value, 1, is now 0, and the maximum value, 15, is now 1. The other values fall proportionally between 0 and 1. Let's dive deeper into why this transformation occurred and what it means. We're applying the MinMaxScaler technique from the scikit-learn library. This is a data preprocessing step used to scale numerical features in a dataset to a specific range, typically between 0 and 1. It helps to normalize the data, ensuring no single feature dominates due to its scale. This is our starting point, a simple feature vector, x, containing the values 1, 5, 10, and 15. These could represent anything, measurements, scores, or any other kind of numerical data we're working with. We want to scale these values using MinMaxScaler. As mentioned, MinMaxScaler is an algorithm that transforms features by scaling them to a range between 0 and 1. It does this by subtracting the minimum value from each value, and then dividing the result by the difference between the maximum and minimum values. This represents the resulting feature vector x after the min-max scalar transformation is applied. We'll calculate its values using the formula mentioned earlier. The core of the exercise is to test our understanding of how the transformation affects the data. After scaling, we have a multiple-choice question to check if we can correctly analyze the properties of the scaled data. Let's find out. This is the question itself, asking us to determine which statements about the scaled feature vector, XSCALED, are true based on the application of min-max scalar. This is one of the options we need to evaluate. Does applying the formula lead to a minimum value of 0 in the transformed data? Another option to check. The scaling should produce a maximum value of 1. This option relates to the overall range of values after scaling. If options A and B are correct, this should follow automatically. Here's a statement about the mean. The min-max scalar doesn't necessarily preserve the mean. Let's verify if it remains at 0.5 after the scaling. Min-max scalar is a scikit-learn preprocessing technique. It scales numerical features to a range between 0 and 1. Think of it like adjusting the volume of your music. You make sure the quietest part isn't too quiet and the loudest part isn't too loud, but everything else is relative in the range. This helps algorithms work better since they don't always handle different feature scales well. This line simply presents the input data, a feature vector x containing the values 1, 5, 10, 15. It's the data that will be transformed by min-max scalar. This is one of the multiple choice options. Min-max scalar guarantees that after scaling, the smallest value in the transformed data will be 0. Another multiple choice option, min-max scalar, ensures that the largest value becomes 1 after transformation. The final multiple choice option. As a direct consequence of options A and B, the range of the scaled values will be between 0 and 1, inclusive. This statement explores whether the mean is preserved after the transformation. The min-max scalar does not guarantee that the mean will remain 0.5. While it might be close, it won't always be exactly 0.5.